Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will deep dive into one of the best MLOps platforms, that is Kubeflow. So you will learn what is Kubeflow, why Kubeflow, how it helps in ML workflow and MLOps. You will also learn what are the different components of Kubeflow. Especially we will deep dive into one of the important components of Kubeflow, that is Kubeflow pipelines. Then I'll also show you how to install Kubeflow pipelines, how to write your very first Kubeflow pipeline by taking a hello world example. And then we will deep dive into a real world example using Kubeflow pipelines. So we will take a real world model and try to understand Kubeflow pipelines better. This video is going to be very interesting. Make sure you watch it till the end. Even if you don't have any prior understanding of Kubeflow, or if you don't have any prior understanding of MLOps even, trust me, by the end of this video, you will find it significantly beneficial. I also have complete notes that is required. So whatever commands that I execute, I will share a GitHub repository in the description. By following the same, you can also perform the demonstration. So without wasting any time, let's get started. First things first, what exactly is Kubeflow? So to understand that, let's go a step back and start with understanding what is machine learning lifecycle. So just like traditional software development lifecycle, so to build an application, there are various stages that are involved, or to ship an application to production, there are multiple stages that are involved in traditional software development lifecycle. For example, let's say you're building an e-commerce application. Initially, planning is required, then requirement gathering and analysis of the requirement is required, then high level design and low level design. After that, developers work on implementation, which is developing the application and also maybe writing some build scripts. Then the application has to be tested, then the application has to be deployed, and finally, application has to be constantly monitored. And this is not a one-time process. This is a very iterative process. That means maybe after the initial planning, a new feature request might come from your client or maybe from the business. So whenever there is a new feature request or even when there is a bug, probably a new high level and low level design is required. Again, developers work on the implementation, build, testing, deployment, and monitoring of the application. So because this is a quite iterative process, DevOps came into picture. Because if every time developers have to manually do this entire process, it takes a lot of time for them. So DevOps is something that aims at unifying development and operations. In simple words, DevOps is something that tries to eliminate the operations effort. So for that, DevOps engineers introduce various platforms or various tools at different stages of software development lifecycle. For example, during the build stage, DevOps engineers might come up with the build tools like Maven or Gradle, depending upon the programming language. Even for deployment, DevOps engineers come up with continuous delivery. For testing, continuous testing. For monitoring, DevOps engineers comes up with observability platforms. So not only CI/CD, but at different stages, DevOps engineers introduce different tools to reduce the manual effort that is involved in software development lifecycle. So this way, application, maybe if there is no DevOps, if it goes to production in, let's say, 3 months, or for every feature, let's say the production time is 3 months, with DevOps, the production time might come down to 1 month. And the entire process is quite effective without any manual intervention. Now, if there is software development lifecycle involved for traditional application development, there should be something for model development as well, or there should be something for machine learning as well. Exactly, that is where machine learning lifecycle comes into picture. So just like software development, when model development is required, or when a company is working on a new model, there are various stages. First one is problem definition, just like you're planning. But here, what kind of model are you working on? What exactly is the problem statement? Maybe weather forecast, right? Or maybe predicting if a patient has diabetes. So first, problem definition or problem statement is the first stage of machine learning lifecycle. Now, depending upon the problem statement, the machine learning engineers work on developing the model, identifying the exact machine learning algorithm, etc. Then for any model, or even for ML and AI, data is very, very critical. Let's say your model has to predict weather, or it has to predict climate of a particular place. It needs huge amount of data. At least it needs the data for the last 30 years, for the last 40 years, so that your model can be trained on the data and it can give you accurate results. So more the amount of data, more is the accuracy of machine learning models. So that's why data which is relevant to the problem that you're solving needs to be collected. Of course, this data will be in quite unorganized format. So then the data analysis and data serialization is important. And then what kind of feature engineering? Probably, you will keep working on different features. You might not develop the model in one single go. It will be an iterative approach. So feature engineering is involved, or you can call it as development that is involved. Then the model has to be trained with the data. In this stage, you might identify the algorithm that is required, right? Once you identify the algorithm, such as random forest or isolation forest, whatever it is, then the model has to be trained with the data. Now, once the training is done, the model has to be evaluated, because your machine learning model, it might have 60% accuracy, it might have 80% accuracy, or it might have 99.9% accuracy. Imagine you go to a hospital and you get a report or a scan done. Now you give this scan to a machine learning model. So a company has developed this model. What it does, it looks at your X-ray scan and it tells you what exactly is your problem, or maybe it tells you if you have a fracture or there is no fracture involved. So this machine learning model, it will be trained on data. So maybe hundreds of thousands of images, X-ray images, it will be scanned on. And depending upon how better model is developed, accuracy will be based on that. Of course, it will be based on machine learning algorithm. It will be based on how well it is trained, and also how much data you provide to the model. Now imagine if this has only 60% accuracy, then that's a big problem, because you cannot use it at least to your patients. Because if the model accuracy is low, that means there are high chances, even if the patient does not has a fracture, but still your machine learning model says, okay, there is a fracture. So that's why model has to be constantly evaluated and it has to be tuned. Then the model has to be deployed so that people can access it. Maybe during the deployment, you package it with a software application, and maybe you deploy it as a website or as part of a website. And finally, monitoring of the model. And during monitoring of the model, a retraining of the model is also required, because as there is new data that is coming in, models efficiency usually goes down from 99%. Whenever new data is added, your model efficiency might come down to 90%. So again, your model has to be trained with the new data. Again, your model has to be evaluated, your model has to be tuned, and your model has to be deployed. So just like software development lifecycle, this is also an iterative approach. And even when you compare with software development lifecycle, machine learning lifecycle is very iterative approach. That's one of the main reasons why lot of machine learning engineers, they have the model on their laptop, but they don't ship it to the production. And a study says almost 80% of the models, they are buried in the laptops of the ML engineers, but they haven't reached the production because of this same problem. You know, initially the efficiency of the model might be high, but every time as the data keeps coming in, the efficiency keeps going low. Or every time there is a feature requirement, the efficiency of the model keeps going down. Now, how can someone help with this iterative approach? So taking DevOps as an inspiration, MLOps came into existence. What MLOps does? It does the same thing as DevOps. Now, if you understand what exactly DevOps does, MLOps is an extension and it is related to machine learning lifecycle. At each stage of machine learning lifecycle, wherever operations is involved or wherever lot of manual effort is involved, MLOps, let's say MLOps platform or MLOps engineers introduce tools or introduce components to solve that particular operations effort. Let's talk about data loading, or let's talk about data analysis or model training. Imagine if there is a tool that improves the efficiency or significantly reduces time that is taken versus someone who is doing it manually, right? Just like CI/CD for DevOps engineers, if there is CI/CD for ML workflow, wouldn't that be awesome? And that is what MLOps does. Of course, it's beyond CI/CD, just like how DevOps is beyond CI/CD. DevOps is also monitoring. DevOps is also constantly observing the state of the application. Similarly, MLOps is also CI/CD for ML workflows, plus monitoring of the models, plus tuning of the models, everything that is required to reduce the operations effort. Now, what is MLOps? MLOps is machine learning operations. What MLOps does? It unifies or it bridges the gap between machine learning and operations that is involved in traditional machine learning lifecycle. But Abhishek, do I need to learn various tools just like how I learn various tools as part of DevOps? Do we need to learn various tools to learn MLOps and to implement MLOps for a company? Definitely, the answer is yes and no. Because when it comes to MLOps, there are standalone platforms. What we are going to learn today, a standalone MLOps platform, that is Kubeflow. Or you can deal with individual sets of tools. Either you can add, if you're working as a MLOps engineer, either you can add a tool at every stage of your machine learning lifecycle, or you can go with a comprehensive or standalone platforms like Kubeflow or MLflow. Of course, MLflow is out of context for today's video, but just understand it is another platform that also helps at solving the same problem. However, Kubeflow is more sophisticated platform. So it comes with more robustness when compared to MLflow. Now, Kubeflow, as I told you, is not a single tool or it's not a single project. Basically, it's a collection of components, right? So within Kubeflow, there are various components. So it's a combination of projects where each of the component aims at solving the operations involved in machine learning lifecycle. Now, if we go back and talk about stage by stage, we were talking about loading of the data, right? For loading of data, you can use a component of Kubeflow, which is Kubeflow pipeline. So Kubeflow pipeline can help you with loading of data. It can also help you with, to some extent, training of the data, right? And then there is Kserve, which can help you with deployment, model deployment, and exposing it to external world. There is Kubeflow notebooks, which is useful for execution. So usually ML engineers, whenever they write the Python script, they use Kubeflow notebooks or Jupyter notebooks, and it is very easy for them to evaluate step by step or execute part of the programs. Then there is Catib. Catib is used for hyper tuning of the model. Don't worry, we will understand step by step. Catib is used for hyper tuning of the model. Then there is model registry. I'm sure you all know what is a model registry. Just like how you have traditional application registry or a container registry, similarly, you have something called model registry. Overall, you have the Kubeflow dashboard, which is serving as UI, user interface for the complete Kubeflow project. If you consider all of these projects under one roof, that is Kubeflow, Kubeflow dashboard helps you with the user interface. Just like how you have AWS, within AWS you have multiple services, whereas you have a single dashboard or user interface for AWS, right? To access EC2 or to access S3 bucket, you use the AWS user interface. Similarly, to access these projects, you have Kubeflow dashboard. Now, just to repeat, as you have seen, there are multiple stages involved in machine learning lifecycle. So for data collection or loading of the data, Kubeflow pipelines, let's call it as KPF. It is actually called as KPF very shortly, right? So there is something called KPF in the short notation of Kubeflow pipelines. Then data analysis, and when it comes to feature engineering and selection. So for the feature engineering and selection, the Jupyter notebooks or Kubeflow notebooks can be used. For training, Kubeflow pipeline can be used, which is a component of Kubeflow. Along with that, there is also a training operator. So within Kubeflow, there is also a component called training operator that can also be used. For model evaluation, again, Kubeflow is very good, and you have Kubeflow pipelines for the same to evaluate the efficiency of your model. For model deployment, there is Kserve, and for monitoring of the model, you can integrate Kserve with observability platforms like Prometheus, Grafana, or any other popular observability platforms. So this way, Kubeflow has components for each stage of machine learning lifecycle, right? So Kubeflow is a end-to-end MLOps platform. Now, Abhishek, do I have to learn Kubeflow project altogether? Like, can I learn individual component? Yes. And that is the best approach to learn Kubeflow. Like, instead of diving into all of the components at once, because when you're learning DevOps, you don't learn DevOps altogether. You learn build, you learn deployment, you learn CI/CD as different components. Similarly, even when it comes to MLOps, do not learn it all together. You will find it overwhelming. Instead, if you are learning Kubeflow, learn it component by component. And the most important component is Kubeflow pipelines. Why? Why is KFP, which is Kubeflow pipelines, very important? Because it can help you with, it is just like CI/CD for DevOps, and it can help you with data loading, right? It can help you with training of the data or training of the model. It can also help you with evaluation of your model, right? So when you provide your model or when you run it as a pipeline, So it can perform all of these things. When we try with an example, you will understand. Like we have two examples in today's video. One is Hello World and one is a model. So then you will realize how KFP solves different stages of the machine learning lifecycle. So go component by component. And the best part is that Kubeflow allows you to do that. Either you can install the entire Kubeflow at once, or if your company don't want to use, let's say, Kserve, or if your company is not interested in using Kubeflow training operator, or maybe Kubeflow notebooks, you can also go and install one of the component standalone. That is what we are going to do now. We will install Kubeflow pipelines as a standalone solution. You have a very good documentation. Don't waste your time going to different sources of documentation or visiting different websites, because within the Kubeflow documentation, you have perfect installation steps. If you want to install Kubeflow altogether, you can just go to getting started and installing Kubeflow. Or if you want to go with a particular component of Kubeflow, so instead of installing it as a whole thing, go to Kubeflow projects, select the project that you are interested in. Do you want to install Catib? Do you want to install model registry? Do you want to go for Kubeflow trainer? We want to go with Kubeflow pipelines. And within this, just go to operator guide and click on the installation section. That's it, you're good enough. But Abhishek, I want to install the entire Kubeflow. There is something called mini mini KF, my bad. So mini KF is a solution that can help you, just like Minikube. It's a solution that can install Kubeflow on your laptop. However, it only works better on Windows. As per my recommendation, go step by step. So we will start with Kubeflow pipelines. Now to install Kubeflow, you need a Kubernetes cluster. But Abhishek, why do I need a Kubernetes cluster for this? Like, the thing is, Kubeflow is a solution that is very tightly coupled with Kubernetes. And the goal of Kubeflow, or the whole purpose of Kubeflow, is also to implement the machine learning lifecycle on a Kubernetes cluster. So when we are writing the Kubeflow pipelines, as I told you, which is just like CI/CD, each and every stage that you're writing, it can be loading of data, it can be training of data, or it can be evaluation of data. They actually run as containers or pods within your Kubernetes cluster. So Kubeflow is very tightly coupled with Kubernetes. And the name also says that, right? Kubeflow. So you are implementing machine learning lifecycle on a Kubernetes cluster. So we need a Kubernetes cluster for it. Very simple. Whether you have a Windows machine, whether you have a Linux machine, or even a Mac OS, all that you need to do is go for Kind. Kind can help you run Kubernetes cluster in minutes. You need Docker desktop for it. So on your laptop, install Docker or Docker desktop. So I have Docker running. Let me recheck. Okay. So I will try to run Docker PS, Docker images. Perfect. So I have Docker running on my machine. Now, what is the second step? Second step is you need to install Kind. But Abhishek, where do I find these steps? As I told you, I have prepared a GitHub repository for you. So this is the GitHub gist file. It's not a repo, it's a gist file. So within this GitHub gist, you have the installation guide and also the pipelines that we're going to run. Okay. So in the installation, first step is to install Docker desktop. Second step is to install Kind. If you're not sure where to install Kind from, just click on this link, select your operating system, and as per your operating system, go ahead and install Kind. Again, I have Kind running on my machine. Kind get cluster. There are no clusters, but that's okay. We'll create a cluster. If you're not sure about kind, if you're completely new, I have a complete tutorial on kind. I will try to put that description as well. Kind create cluster hyphen name is equals to KFP demo YT. Okay, so I'm creating a cluster KFP, which is a shorthand for Kubeflow pipelines. We should have a cluster in less than a minute. Perfect. So kubectl get nodes. Okay, so kubectl is connected to the same cluster. We are all good. Now, just go to the documentation. You can also go to Kubeflow official documentation. Deploy the Kubeflow pipelines. These are the commands that you need to run. Now, what exactly are these commands doing? First, the version of the Kubeflow pipeline. We are exporting a variable and we are applying the configuration to install custom resource definitions or CRDs that are related to Kubeflow pipelines. As I told you, Kubeflow is tightly coupled with Kubernetes. So end of the day, you write a Python script, you load that Python script, and using the Kubeflow package, Python package, you compile that to a YAML file, right? So what exactly we do with Kubeflow? First, we write a Python script, or developers write a Python script, ML engineers. Then there is a Python package called KFP, same thing, Kubeflow pipelines. So you install this using pip. What this KFP does? So KFP compiles your Python script to a YAML file, and this YAML file is submitted to the Kubernetes cluster. And when it is submitted to the Kubernetes cluster, this Kubernetes cluster runs containers or it runs pods, right? For each stage of your Kubeflow pipeline. So let's say you have three stages, one for loading of data, one for training of data, one for evaluation of the model performance, then three containers, or at least for loading and training, two containers or two pods get triggered on your Kubernetes cluster. So it's a complete cloud native thing. Just like if you're using GitHub Actions, how for each stage of your pipeline or each stage of your workflow, how there is a virtual machine that is created, and within the virtual machine, how you have um, your workflow running or your actions running within the virtual machine. Similarly, when it comes to Kubeflow, containers are run within the Kubernetes cluster. Your Python script is compiled to the YAML file using the KFP module. We will do all of it. Okay, going back. So this installs CRDs and then it will wait for the CRDs for 60 seconds. And finally, this particular kubectl apply, it will install all the pods related to Kubeflow pipelines. This entire thing will take 3 minutes of time. So please wait for it to complete. And also there is a very important note in the Kubeflow documentation. For some reason, if this does not go well on your laptop, so there are cases that it doesn't work on specific Mac OS or it doesn't work on Windows. So what you need to do is just delete the pods that are created and then just run the platform agnostic kubectl command. So instead of this command, you just need to run this command. The first CRD command will stay intact. Only thing that will change, instead of this one, run this. Personally, I also ran into this issue and I have also commented on the Kubeflow GitHub repository. So I noticed there is a bug that is open. I also commented my findings. If I have time, I'll also create a pull request for the same. Going back. Okay. So let's see. kubectl get pods hyphen in Kubeflow. Okay, containers are creating. An interesting thing to note, if you're wondering, Abhishek, which CI/CD platform or which CI solution Kubeflow use under the hood, it is actually Argo workflows. So the controller that you see here, workflow controller, is Argo workflow controller. Okay, so all the pods are in the running state. Now let's go ahead and access Kubeflow pipeline dashboard. So we will access KFP dashboard from the browser. To do that, all that we need to do is port forward the ML pipeline UI. So again, this is one of the pod. This is one of the service. So we will just port forward the service so that we can access it from our browser. So on the terminal, I will fire this command. Once port forwarding is enabled, I can access it on localhost 8080. Okay, localhost 8080. Perfect. So we have the Kubeflow pipeline dashboard here. So we have done the installation. What have we learned till now? Very quickly. So we learned what is Kubeflow. We learned why Kubeflow. We learned about ML workflow and MLOps. We learned about different components of Kubeflow. We will go ahead and write our Kubeflow pipeline, very first one, but we learned how to install Kubeflow pipeline as well. Cool. So now we have the dashboard. So let's see how to write the pipeline. The interesting part here, as I just mentioned sometime back, when it comes to Kubeflow pipelines, we will not actually write the YAML file, but we will use the same Python program. So when developers are working on developing the model, so they must have written a Python script or they must have written a Python program. We will use the same Python program. We will use something called DSL, which is domain specific language. And we will compile this Python file to a YAML file. If you are thinking this is difficult, to be very honest, this is very, very simple because you don't even have to write the YAML file. Python file is written by the ML engineers. You just need to add DSL. But Abhishek, what do we need to add with respect to DSL? I will show you. There are some pre-built functions. There are some pre-built annotations, decorators, input, output within DSL. We will use it and we will compile this program to the YAML file. And then we will simply upload this YAML file to the Kubeflow pipeline dashboard. So here you have an option to upload the pipeline, create new pipeline. Let's say I'll just say test, upload a file, choose file, and I can upload the YAML file that is compiled. But for that, we need a Python program, right? So first, as I told you, I'll just show you with a hello world program. Let's go back to the terminal for it. I'll just take a new tab. We will keep this session so that we can access the Kubeflow pipeline dashboard. Just duplicate it. Perfect. We have another session. Let's create a new folder. I will call it as KFP CD KFP. Whenever you're working with Python, it's not only for your machine learning, it can be for even your DevOps project. Make a habit to create virtual environments in Python. Because when you're dealing with multiple Python programs or different kinds of Python programs, there is a possibility you will run into dependency conflicts. Let's say you're using Python on the same machine for writing a DevOps script and you're using Python for your machine learning. There can be a common dependency with different version, which leads to a conflict. So always it's a best practice to create a virtual environment, which is very simple. Python 3, you should just have Python installed, Python 3 -m venv, which is virtual environment, followed by, I'll just call it as .kfp. Again, whenever you create a virtual environment, make a habit to create it as a hidden folder, because you can just, you don't want others to view what is in the virtual environment. It's not very important. Also, when you add a .gitignore file, it's very simple to add the hidden files in it. Okay. So Python 3 -m venv, I just created the virtual environment. Now I will source the virtual environment. Source dot kfp bin activate. Now what this does, anything that is installed within this virtual environment will only be restricted to that virtual environment. If you deactivate it, like if you just run deactivate, you come out of the virtual environment and the package that you have installed in it will not be on the machine. Okay, so again, I source the virtual environment. The very first thing that you'll install, pip3 install kfp. You can install a specific version of KFP. I would actually recommend that. So go ahead and install KFP 2.9.0. If you are using Python 3.10 and above, you can install directly pip3 install KFP. But if you're using 3.9, 3.8 on your machine, make sure you pin it to this particular dependency version. Okay. So what is KFP? KFP is Kubeflow pipeline. So we will be using this SDK or package. We'll use it for creating the pipelines. Okay. Now, how do we write the pipeline? As I told you, we need a Python program. The Python program, I will open it for you. So this is a hello pipeline.py. Within the pipeline, most of these things are shared by the ML engineers itself. Only thing that you would add, as I told you, you will add the DSL decorators. So for every component within your Python program, basically in Kubeflow, different stages of your ML lifecycle are considered as components. As we saw here, there is a stage for data collection or data loading. There is a stage for model training, model evaluation. So each of these things in Kubeflow is considered as a component. So your ML engineer must have written a function for model loading or data loading, must have written a function for data training. Just add a decorator to that function. At the rate is for decorator dsl.component. So when you say dsl.component, Kubeflow will understand, okay, this has to be one of the component of the pipeline so that it can be reused, right? From this point to this point, which is your definition in Python, should be one of the component in Kubeflow pipeline. What happens if it is a component? Basically, for this component, a pod is created and this pod is executed independent of other components so that you can maintain scalability, you can maintain parallelism within your Kubeflow pipelines. So every component has a unique pod. And from wherever you invoke this Python function, so this one is say hello. So you are invoking this from, let's say, a hello function. So there you need to add the decorator for dsl.pipeline. So now this dsl.pipeline is basically the orchestrator. So there are different stages in your ML pipeline, right? Or in your machine learning workflow. All of these components have to be orchestrated, just like how you orchestrate with Jenkins or GitHub Actions. So there you add a decorator called @dsl.pipeline. Very simple. So if we take a real world ML pipeline, you might understand it better. So here we are using a model, and this model will focus on identifying the type of the flower. Okay, so you are writing you are building a model by taking some parameters. It will identify what kind of flower it is. For example, are you dealing with Setosa, or are you dealing with versicolor, or are you dealing with Virginicea? So all that you have to do is you have to provide the sepal length, sepal width, petal length, and petal width. If you provide these four as input to your model, depending upon the input parameters that you have provided, it will identify what kind of species of flower it is. Now for this you need a data set, obviously, and this data set is going to be your iris data set, which is a publicly available data set. So the ML engineer within the Python program first will write a function for loading of data, where the engineer will load the iris dataset. Then there is a function for training of the model. So this is one of your ML stage. This is another stage, which is training of data. And finally, you have an orchestrator, which will orchestrate both loading of data and training of data. That's why for these components, or for the stages in ML workflow, you will add @dsl.component and any dependencies that are required in the container image, because it is running as pod. Let's say within your load data, if you are using pandas to read the data from Excel, or to read the data from a data set, so you have to add this packages to install pandas and scikit-learn. Similarly, in your second stage, again you will add @dsl.component packages to install scikit-learn, whatever packages are required. As you keep working on the ML workflows, you will understand the packages, and even you can get this information from your developer, like what packages are required to run this particular stage, or for this Python program to execute, what are all the dependencies, so that you can add the dependency for each of the component. And finally, as I told you, @dsl.pipeline, where these functions are actually getting invoked, load data, train model. So you just provide it with a name and description. You can also skip it. It's not mandatory. Finally, the last stage is to compile. So this Python program has to be compiled to a YAML file, and that YAML file will be published to the Kubernetes cluster, or that YAML file you need to upload to the Kubeflow pipeline. So as an MLOps engineer, what are the things that you'll add? For every function, you should add dsl.component. If not for every function, wherever you feel a stage of machine learning it is dealing with. So for example, loading of data, add dsl.component, training of data, add dsl.component, and where these functions are getting invoked or components are getting invoked, just add @dsl.pipeline. Finally, where you have your main execution, just compile this Python program to a YAML file. So this code will always remain the same. kfp.compiler.compiler.compile name of the Python function, and what should be your YAML file name. You will realize when I execute these programs. First, let's execute the hello world itself. So I will just copy it. You have these within the GitHub gist. Okay. So here I will create hello underscore pipeline.py, right? Is the naming correct? Let me just recheck. Yes, hello underscore pipeline.py. In fact, you can change the name. It doesn't matter. From KFP import DSL, from KFP import compiler. These are the only two things that you are doing. You are using DSL and you are using the compiler to compile the program to a YAML file. Okay, so let's save this. Python 3 hello underscore pipeline.py. So it's executed. This is just a warning, you can ignore. ls, you will find hello world underscore pipeline.yaml. Isn't this amazing? You don't even have to write the YAML file. Now, within this YAML file, if you quickly want to see it, right, this will have the pipeline, right? So this will have whatever are the steps that should be executed within the Kubernetes pods. Remember we installed CRD. The reason why we installed CRD, because we can define this particular YAML file. Okay. This is a new resource type. Kubernetes does not understand this resource type. That's why Kubeflow pipeline came up with its own custom resource definition. Great. Now let's go back. Kubeflow pipelines. Let's call it as hello. And from the upload, KFP is the folder. Hello world pipeline.yaml. Let's create it. As soon as you create it, you will see a DAG. So this is a graph which will tell you what is the status of your execution and what is the flow of your pipeline execution as well. I'll click on create run. You can leave these options to default if you are a beginner. As you progress with Kubeflow pipelines, you can start using service account. You can start using the different parameters here. But when you are beginner, you just keep the options to default. You can specify the parameter. I'll just call it as Abhishek. So my Python program should return hello Abhishek. So this is not related to machine learning. This is just your very first Kubeflow pipeline, which will say hello Abhishek, hello world, whatever you pass as the parameter. Just to verify your concepts are clear and also your Kubeflow pipelines are working as expected. Okay, start. You can see the status here, pending execution. In the meanwhile, if we get to the Kubernetes cluster, right, kubectl get pods -n Kubeflow, you will see a pod is being initialized, right? And if you change this to the watch mode, you will realize after some time, there will be new pods that are created. Yeah. So you can see right now, the DAG driver is being initialized. Once this is done, you will also see the implementation pods, and that implementation pods will actually run your pipeline. You can follow the status here. If I refresh, so you should see a pipeline running status once it gets started. Let's wait. So you can see here, the implementation pod is in init state at this point. So if we go back, we should see perfect. So we can see here the loading or the one that is getting ready. And once it is ready and successful, you should see a write symbol here or an execution symbol here, successful execution. Let's wait. We can keep watching the status here, pod initializing. Once this moves to the completed state, we are all good. Still, pod is being initialized. So for the first time, it took some time. Usually it doesn't take time to at least start the implementation pod. Anyways, it is complete. And if we go back, the DAG shows implementation is successful. You can also click on it to view the input, output, and also logs. So within logs, you can see output is hello Abhishek, right? If you rerun this, let's say I create another run, and this time choose the pipeline. I'll choose the same hello pipeline, and I will change this to hello Veeramalla and start. Now you can guess what happens. Go back, you will see a new DAG is created, and again a new implementation pod will be created. So every time there is a run, you will see a pod in the namespace. It's actually not that difficult to remove the pods if you're worried, but it might keep creating a lot of pods. Don't worry about it. It's actually very easy to remove the stale pods within Argo workflows. I will show you that in the next tutorial as we move to the next steps of Kubeflow. Okay, so the DAG is complete, and if I scroll down, implementation is also complete. Okay. And this time in the logs, we should see hello Veeramalla, right? So this is our very first Kubeflow pipeline. Again, this is not at all related to machine learning, this particular pipeline, but this is just to get you introduced to Kubeflow pipeline. Now let's move to the actual one. Okay. So what is our next pipeline? So our next pipeline is a model. So imagine you have a machine learning team, and that team is working on creating a model that takes these four things as input: sapel length, sapel width, petal length, and petal width. By taking these four things as input, the model has to guess if the flower is a setosa species, versicolor, or virginica. This is a very, very popular data set. So you get all four these, all four of these inputs from a popular data set called iris data set. If any one of you learned machine learning in the past, I'm sure you must know about this iris data set. So what the machine learning engineering team has done, imagine if they're working on this. So they will create a function for, or a definition for loading of data. They will create a definition for training of model, and finally they will invoke them in the order. Now, as a MLOps engineer, I know I'm repeating it, but I just want to make sure you understand it. As a MLOps engineer, to convert this into the ML pipeline workflow or Kubeflow workflow, you need to import KFP, you need to import DSL, and you need to import the compiler as well. And for every stage of your ML flow, you convert that to a component into your Kubeflow by using @DSL component. So load data is a component, and I want to use Python 3.8 as image for this container, which is running this particular stage. And because I'm using pandas here, right, within this, I'm reading the data. I'm going to use pandas and scikit-learn. So I'm importing both of these. So packages to install pandas and scikit-learn. And for the next one, which is training of data, I can look at this function. What is it doing? If you don't understand, let me quickly explain. So it is reading the iris dataset here, and here it is training the model. So a machine learning algorithm is used, which is random forest classifier, and this algorithm is being trained in a way. How is it being trained? So 80%, what does this 0.2 signify here? 80% of the data is used to train the model, and 20% is used to verify the accuracy of the model. This is a very common thing that ML engineers do. Train, test, split. Okay, now that we have it, and in the last stage, compile kfp.compiler, compile this to a file called irispipeline.yaml. Okay, we will copy this as well, and we will see how this works. My Kubeflow is still running in the KFP vim iris underscore pipeline.py. You can name it anything. Let's save it. Python 3 iris underscore pipeline.py. Okay, did it create? Perfect. So it created iris pipeline.yaml. Let's go back to our Kubeflow browser, upload the pipeline. Let's call it as flower species identifier. So this is the name of the pipeline that I'm giving. Upload the file, choose, let me choose irispipeline.yaml. Create. The DAG shows there are two things in the pipeline, or there are two components. One is the load data component and one is the train model component. Create the run. Okay, I'll leave the options to default and click on the start button. Again, just like we saw in the previous example, kubectl get pods. So the driver, DAG driver is being created. DAG driver is successfully created. You can see how fast is it this time. Implementation pods are also running. So first one that is running is load data. That's why you see the symbol here. Let's see once it is complete. Right now the pod is being initialized. Once it is complete, we can also see the logs for it. Running. Okay. Refresh this. This should change to complete. Okay. Of course, we can view the logs. So we can just copy this pod and we can see what is the status. We can also see it here. Great. Everything looks good. Let's wait for the implementation to be completed. Great. So this is complete. Now we can see here the entire logs. So the load data is complete. So this is the data. You can see 4 input parameters. As we discussed while going through the code, the 4 input parameters are sepal length, sepal width, petal length, and petal width. So these are the 4 data points in the data set. It's a huge data set and it is completely loaded. Okay, great. Let's see the status of the other one. The other stage, which is train data. Right now, execution is in progress. Logs. Perfect. Train model is also complete. Logs. And what is the accuracy of the model? Accuracy of the model is 0.9. So you have trained the data on these data points. Of course, this code is written by the machine learning engineer, but what you can see here, the accuracy of the model is 0.9. But Abhishek, what did we achieve with this, right? End of the day, why did we create this pipeline and what did we achieve? So this is a very interesting question. What we are trying to do here, we are trying to reduce the effort of machine learning engineer or the developer. Now, next time, if they add few more things to the data, again, they don't have to manually run the load data. They don't have to train the model and see what is the accuracy of the model. If they are changing the data somewhere in the Python function, let's say instead of this data set, instead of iris data set, let's say they are moving to a different data set, or maybe they are adding few things to the iris data set. Obviously, load data will change and accuracy of the model will also change, increase or decrease. So they can just come here, they can create a new run because you have already created the pipeline. All that they have to do, they have to create a new run, and with the new run, they can see what is the accuracy of the model. Did the model accuracy go down or did the model accuracy go high? That's it. So this is what you're doing as MLOps engineer. There are only 2 stages at this point. Imagine if there are 10 stages, you have reduced the effort that they need for 10 stages. Every time they can just come here. Once the execution is complete, they can look at the accuracy of the model. Okay, right now accuracy is 0.9. Maybe after next run, accuracy will change to 0.89 or maybe 0.7, 0.6. So they can again fix their code and rerun the pipeline, see if the accuracy has gone high. So this is about Kubeflow pipelines. In the next classes, we'll also take a look at other components. But if you are focusing on MLOps positions, or if you want to become an MLOps engineer, the most important one for you is Kubeflow pipelines. So just try to implement the demonstration. Everything is in this GitHub repository. I'll put this link in the description. Just follow the same steps and give it a try. See you all in the next video. Take care. Bye-bye.